We've begun to learn about standing waves. The first thing I want to point out is, so you've got this string here, and you've got this mechanical oscillator that's going to go up and down, and you might think that as soon as we turn this on, a standing wave is produced. But watch what happens. This thing is oscillating up and down, and if we turn the camera over, does it look like a standing wave? It looks kind of random, doesn't it? That's because only certain frequencies will produce standing waves. When we fix the frequency, look at what happens. Now you get this nice standing wave pattern. There is a spot in the middle where the string doesn't move at all. That's called a node. And there are these spots kind of here and here where the string goes really high and really low. That's called an antinode. Now we can watch this in slow-mo. Let's watch this in slow motion so it's easier to see. The string is vibrating up and down, and you can see this point right here literally doesn't move. But right over here on the string, it goes really high and really low. Now, we don't have to do this with a single standing wave where you have like an entire wave shape. We could do this with just a half of a wave shape, or 1.5 wave shapes. How do we change from these two antinodes to just a single antinode? We adjust how quickly the oscillator on the left moves up and down. So let's watch that process. We're going to move this thing less frequently at a slower rate and watch what happens to the standing wave. When you don't shake it as fast, you get a single antinode with just the two nodes at the ends. And here it is in slow motion. To understand how these standing waves are formed, we have to slow things down a little. So let's use a simulation to watch the formation of a standing wave. If I hit play, the continuous wave travels across, and then it reflects back when it hits this. And the reflection is what creates the standing wave. In fact, you can see how far the reflection has gotten traveling the other way based on where the standing wave is located. Let's watch that again. The wave travels down, and when it reflects, the reflection interferes with the oncoming standing wave. So more waves keep getting produced from the left. They keep on traveling to the right. And now you have another wave traveling to the left, the reflection. And it's to here and then here. And that's what creates the standing wave. It's formed because you have two identical waves. The green is the regular oncoming wave. The blue is its reflection. They're identical. And when they move in opposite directions like this, at certain frequencies, they combine to form the red resultant wave, which just stands in place. On the red wave, you see that the crests don't move across. They only go up and down, standing in place. So why are there certain places that always reach the highest and lowest, antinodes, but other places that never move up or down, nodes? To understand how those are created, we need to look at the two traveling waves again. Let's watch this antinode where my cursor is, but don't look at the antinode. I want you to look up here at the two traveling waves that create this antinode. And what you will start to notice is that those two traveling waves are always on the same side of the zero line. At this location on the string, if you move over from the left edge and you stop at this spot, the red is a positive wave at this point. It's not, it's right about here at like maybe 3 or something if you look over to the y-axis. And the blue is also a positive wave at this location on the string. So they interfere constructively. They add together. If we let a little time pass, now they're both negative, but they're still the same sign. So they still interfere constructively. More time, they're both negative. That's constructive. They're still both negative. That's constructive interference. Now they're both positive again. So antinodes are places where the two waves always interfere constructively. You know where this is going. Let's look at this node right here. And if we trace up at this location along the string, I don't know how far you are from the left edge, but whatever it is at this location, the red is right here on the graph and the blue is down here. So they interfere destructively. They cancel out, giving no displacement. And if we let a little time pass, right? At this node, blue is positive at this location, red is negative. That's destructive. At this location where my mouse is going vertically, red is negative, blue is positive, so destructive. Now, at this location, red is positive and blue is negative. So they're always interfering destructively at a node, giving zero displacement. So here are the big takeaways. Standing waves are formed as a result of reflection. That reflection creates two identical waves traveling in opposite directions, and they interfere to produce the standing wave. Nodes are locations where that interference is always destructive. Antinodes are places where that interference is always constructive.